Hello, we are Team 32, and over the last few months, we have been working on creating the third version of MotionInput. Our main project partner is UCL in collaboration with Microsoft, IBM, and Intel. So with MotionInput utilizes machine learning and computer vision to allow the user to interact with their computer through just their web camera. Last year, a team of master students were able to provide a proof of concept showing the potential for MotionInput. This year, however, we aim to make MotionInput more efficient and extendable as a software, with the addition of new capabilities. The following requirements were set. Create the new architecture that is designed with extendability and configurability in mind, while maintaining the previous version's functionality. Implement the new scalable frame-by-frame processing logic, allow for simultaneous use of ML models, thus allow, for example, to use hands, head, and eyes modules at once, and create detailed and usable documentation, and thus enable other developers to easily create new gestures and use case specific apps based on the software. So let's have a closer look into this big new architecture of ours. As we're developing it, we split the backend into two layers. Firstly, the core layer that contains all the gesture detection logic. It is fully configurable, meaning there are no hard-coded gestures events or modules in the core code. And then the rest of the classes that either help us initialize the core with our desired functionality or control and support it during the frame-by-frame processing. In order to optimize gesture detection in the model, we are now using observer pattern and leveraging the real-time nature of MotionInput and the fact that between majority of frames, the gesture does not really change. MotionInput 3 allows for a wide range of ML to be integrated in different modules, including but not limited to media-by hands for high-fidelity hand tracking, media-by pose for full-body interaction, dleap allowing for accurate facial recognition, OpenVINO for eye gaze inference, and BOSC enabling speech recognition. What helps us use these heavy technologies simultaneously is the fact that for each frame, all modules are processed in separate threads.
For a demo of the extremity trigger mode, this is a clip of it being used to play 248, with the 4 hit triggers being mapped to the left, right, up and down arrow keys to move the blocks on the screen. Next, we have a new mode developed with walking on the spot being used in conjunction with the triggers to create a Gamepad Mode. Here, it is being used to play Sonic with the left trigger pad controlling movement with walking and the right pad for actions such as jumping.
Firstly, it is shown that the user can use multiple modes simultaneously, in this case controlling the mouse with the hand and left, right and double click with the head gestures. Then the mode is switched to nose tracking and the scroll event is performed.
In the hands module, the cursor is controlled by your palm's movements. The mode supports all the basic controls like right click, left click, dragging, double clicking, and also scrolling and zooming. I would also like to demonstrate how easy it is in our system to add a new hand gesture, like for example middle and ring finger pinch, then use that gesture in a new event, let's say a new type of double click, and then use the event we just created in place of our previous one. And all of that by just changing some JSON files and not having to recompile any code.
Throughout our project, we have achieved a number of feats. Our JSON file system allows functionality to be altered without recompiling any code, making it highly configurable. Our new frame-by-frame processing logic greatly increases efficiency. The system created is modular, making it perfect for developers to make use case-specific apps. We have developed documentation thoroughly explaining the architecture, and we have successfully shown our architecture working throughout the production of multiple microbuilds. And here are some links for a closer look at our work. Thank you.